Hi, I'm Paul. I'm going to present you hydrostatic pressure experiment. Let's start with the introduction. These are the members of Group 1. Amjad, Sairul, Hannah, Zaim, Pichin, and me, Paul. These are the basic theory of the experiment. The experiment explores the hydrostatic pressure in a water column subject to gravity. P equals to rho g h. Rho is intensity, g is gravitational acceleration. The pressure is measured as a function of the immersion depth h using a colored water and ruler. The displayed pressure remains constant when the tube is turned in all directions at a constant depth. The pressure is thus a non-directional quantity. Water is filled in a glass container with a tube is immersed in it filled with water. The tube is secured with a plasticine to avoid it from moving. The air in the tube is compressed by the hydrostatic pressure. The pressure is measured with a ruler and related to the immersion depth with the colored water move. The tube can be rotated about two axes if we secure it at another axis so that the side with the colored water can be moved to face any desired direction. In this way, the independence of pressure on direction can be checked. These are the objectives of the experiment. First, to study the hydrostatic pressure dependence on depth and direction. Second, to determine center of pressure on a partially submerged plane surface. Let's talk about the methodology. These are the apparatus and material used in the experiment. Jug, tube, plasticine, ruler, colored water, water. These are the procedure of the experiment. Step 1. The jug was filled with water until distance of the water surface and the end of the tube is 6 cm. Step 2. The tube was closed by using plasticine. Step 3. The one end of the tube was immediately put below the water surface. Step 4. The tube was secured by adding plasticine at the wall of the jug. Step 5. The water was filled with colored water and make sure there is no bubble. Step 6. The tube was inclined slightly to the left so both meniscus were at the same level. Step 7. The meniscus is marked as 0. Step 8. The differences between the meniscus is measured and recorded with ruler and pen for 3 times. Step 9. Step 8 is repeated with 7 cm to 15 cm with 1 cm increment each by adding water into the jug. These are the experiment video. And this is the result of the experiment. Table 1. Manometer readings delta X at various immersion depths h. To visualize this data, we plot the graph of h versus delta X. As we can see from the graph, the h is directly proportional to the delta X. These are the discussions of the experiment. First, what can be observed from the plotted graph of h versus delta X? H is directly proportional to delta X. Second, what happened to indicate pressure when the pressure gauge is rotated? Is hydrostatic pressure a scalar or vector quantity? Explain your answer. No changes. The hydrostatic pressure is a scalar quantity because when a force is applied at any point, the pressure is equally transmitted to all directions. Third, what do you think will happen if water inside the vessel is replaced with cooking oil? Please explain your answer. Delta X will become smaller. The cooking oil has lower density than water according to basic theory. P equals to rho g h. When the density decreases, the pressure decreases. Fourth, how do you find the accuracy of the measurement in this experiment? What are the errors that might occur? The accuracy is merely acceptable. The accuracy of the result is prone to airflow, parallax error, and thermal expansion of the liquid in the tube. Fifth, please state the countermeasure step that can reduce the errors. Conduct the experiment in an isothermal room without airflow and read the reading at the eye level. Conclusion. From this experiment, we know that the immersion depth h is directly proportional to the manometer reading delta x. The basic theory is true. We also know that the hydrostatic pressure is a scalar quantity.